this is point A. That's good, but I suggest you to try to put the notation so that you won't confuse. This is called FCB and this is called FCA, and there are purpose that we make it like that. Yeah. You hear? You say FA to C, C to B. The result is correct, but if it's very detailed, then this is, can I say, not exactly correct, because the correct one is not F A C and not F, but F C A. So this is F that belongs to C because of B and because of A. That's why it's C, B, and C, not A, not B, C, not B, C. The F of C because of A, because of B. Yeah, so we might want to make the notation a bit better. Of course, the Q is dependent on the QC, QA, and QC, and QB, right? Yeah. Then the next calculation is correct. Yeah. Or if another type of calculation which has exactly the same result is this. It's shorter because we can eliminate FC equal to FCA, put down the formula, and then we have QC. Just eliminate the QC, left and right. K is the same, eliminate the K. So we only have QB by RC squared and QA. Then QB was 2 and QA was 1. And RCB is 2 minus X, RCA is X. Then until it's the same. But yeah, it's a little bit, you're saving time a little bit. Yeah. And here's fine, except for your notation that you need to remember. The calculation is fine, it's just that I want to try to eliminate some variable to make it a bit faster. Yeah. Any question from this example? Is it difficult? This kind of examples? Okay. Alright. Another exercise, but I just put down the answer over there. This is about the electric field. So there's a point X that appears in the electric field. There's electric field and there is a point CX. The magnitude of the electric field strength at point X itself is 0.7 n by C. Yeah, given by the curve. If an object with an electric charge of 0.35 coulomb, this is the Q, is placed at point X. So point X has an electric field of 0.7, but then electric charge is applied to that point X. How much coulomb force will work on the object? So we have the electric field, in this case is E equal to 0.7, and then we have the Q, which is 0.35. Yeah. So what is the force? If you still remember the formula, yeah, F is equal to Q multiplied by P. Okay, S is equal to Q. You just put down the numbers over there. Yeah. So just multiply Q in E, and you get 0.245 Newton. Yeah, it's a simple one. Maybe too simple for an exam. Yeah. Okay. Actually, I have some other, but should I show it to you? Let me check. Yeah, maybe I can cut some and just give you the links and then alright, so this is another example. Say now there are 3 points, Q1, Q2, Q3. Right, location is like this. the distance A, and then this is plus, minus, plus, plus. Previous example was just in the one line, now it's in different position. So we have different direction of F. So if we know Q, for example, Q1, Q3, Q2, plus or minus, and we have the distance, the location. So this is square root of 2 and A. What was the question? Resultant force on Q3. So here, what's the resultant of this 2F? Just use coming back to the engineering mechanics things. Yeah. We don't know the angle. Sure, we just need to use sine or cosine. Going back to those things. Yeah. So F23, F13. Based on A and based on the square root 2 of A. Yeah. This is the magnitude of each F23 and F13. But then we need to find the resultant, of course, right? This is to find out what is F23, what is F13. You know this, Newton, but based on the direction, you need to find out the F resultant. This is this example. There's way too, but you can use the engineering mechanic one. Use it. Sine, cosine. This one he used cos 45. Okay. This is another example because all the previous example was just the line. Yeah. Or another example like this. Q1, Q2, and then this is P. In this case, electric field. So charge Q1 is 7 microcoulomb, Q2 is minus 5 microcoulomb, and then the location was also known with the distance between this point 3 and 4.5. Find the electric field at point P, which has coordinate over here. This is the location of P. Electric field. Yeah. So we have because of F. Q1 and Q2. Remember that the direction of the field is everywhere. Yeah, from Q1 and from Q2. So in that case, then this is also the answer, and using this E now that is being asked in the location. E is equal to E1 plus E2. Yeah, in here. E of from Q1 and E from Q2. Okay, here, and this is the formula of the E. Okay, this we can check it later. I will share you. Okay, and then other again related to electric field. This one, but this is charge Q1, Q2, Q3. And the distance, and also, we know D is same distance but different angle in this case. What net electric field is there's other origin in here. What's the electric field? So E again. Just add all the other E. E1, E2, E3. Yeah. And which we need to find out. And the math comes in. Okay. To find out the total E is equal to this. Okay, you can check it again later. Yeah. I think before that I need to because this is more pages and the other part is not a lot.